Hello, hello.
Well,
Hi. Is everybody ready to get started?
yeah.
That's the energy we want. This is my great friend Dennis. He was the person who helped me get my first patent. Still filing, but we'll call it a patent right now. He has over 25 patents to his name. He has done a number of amazing products. He's a really, really great person. I remember meeting him my senior year in high school, and he helped level up our project, ended up making us a lot of connections. And he has invented everything from a double ratcheting thing to a police light that came out right before the LEDs. Thank you and welcome, Dennis.
I'm pleased to see so many of my friends from Creekside, but before I really get started, I got to give a shout out to my lovely bride back here. Wow. Okay. And she's my helper telling me to speak up. So this is my lovely bride, Lisa. She also is an engineer. She graduated second in her class in engineering, and we met the first week of school 40 plus years ago. And yesterday was our anniversary.
Oh,
And I'd ask her to marry me again, but today is a little rocky. So we're going to get started here. Alex asked me to talk about ideation to execution. So there are going to be elements of that in here. And a lot of this is stuff that I've learned over the years. It's stuff that they didn't teach me in school. Frankly, what they taught me in school was how to learn and how to think. They didn't teach me what to think, but how to think and how to learn. Think of what you guys are learning here in school as Lego building blocks. When you get out into the real world, you're going to walk into jobs that you've never done before. You didn't get trained to do while you were in school. You got to take what you learned and put it together and solve the problems that you're faced. Our kids are, our oldest, we've got twins and we got 5 kids total, but our oldest are twins. And when my daughter was in 7th grade, she was learning word problems. And I was laughing at her right to her face. I said, Ellie, let me tell you something. The whole world is a word problem, and you have to write it. I want you guys to keep that in mind because that's what engineers do. You're faced with a problem and you got to figure it out. You got to figure out how to phrase the problem, and then you got to go solve it. And then you got to communicate it to people. So hopefully I'm going to show you some things today that you're going to go, I can do that. I can use that. That's what I'm trying to do. I'm going to give you some things that you can use. So who is this guy? I'm a curious guy and I'm always learning. I'm not 29 anymore, but I've been learning all my life. Lazy malcontent. I said that to my boss one day. He says, Dennis, you're one of the hardest working guys I know. I said, but Jason, I'm a lazy malcontent. I'm lazy because I'm always looking for an easier way. And I'm a malcontent because I'm never quite satisfied. That hasn't hurt me to have that attitude. I've worked in a whole bunch of different industries. I've got a bunch of different patents and all different kinds of things. And I've been fortunate to have lots and lots of training by virtue of classes I've taken on my own or the companies that I worked for. I encourage you to take all that you can. One of the best classes I ever took was a whole day class just on brainstorming, a whole day. And the techniques that they taught us were so valuable. So you might think, oh, this is a little thing. Soak it up, soak it up. And I have to say, I am living my dream. But I have to caution you that living your dream does not mean you won't have sleepless nights. Ask my wife. This is the baby that's causing me my sleepless nights. There's a story in that. I'm not going to get into it. This is something I designed 37 years ago. It was my first design job. It's not glamorous. It's not sexy. It's just a hanging scale. I'd been working as a lubricants engineer. Then I went to work for this small scale company. That was my first project. That is still in production. That picture's only a year old. These scales are in some major Schnucks grocery stores in the Midwest. They're in Whole Foods, I think. And I was just tickled to death to see it because it's remarkable to have a product still in production that long. This is a ratchet that I've designed. It's really awesome. And then I'm going to talk a little bit about this DTEC technology because it fits in here. So what is product design? Well, it's something that somebody wants. It solves a problem they have, and it makes their life better. That last word is a key word, better. That's what they want. Come on in. We don't bite. All right. Good product design, you have to understand the market, the customer. What do they want? Why do they want it? How will they use it? What are their current options? Because they're currently solving this problem with something, and you're sitting there going, I think I can do better. But you still need to be very much aware of what their current options are. You got to understand what they're willing to pay and when they want it. Timing is everything. Sometimes timing works against you. Ultimately, you have to understand what the customer wants. They get to define value. And so I like Venn diagrams. You may have seen this, or maybe you haven't, but if you haven't, you're going to say, oh, this makes sense. This is fun. When you go to design something or do anything, there's good, there's fast, and there's cheap. But good and fast is not going to be cheap. Good and cheap is not going to be fast. And fast and cheap is not going to be good. And that little luxury spot in the middle doesn't exist. It's impossible to have something that is good and fast and cheap, unless you're stealing something. All right. You guys are all in a top-notch school. You're all taking technical classes. I assume most of you are medical or biomed or something very technical, right? Is there anybody in here that's a lit major? I didn't think so. So this is the higher math. This goes right up there next to differential equations, Calc 3, statistics. We're defining value. Value is the customer's wants divided by costs. It is that simple. You're going to use this. This is something you're going to walk out of here and you're going to remember. I guarantee it, because we do this in my family. The wants can be categorized as the function of the product. How does it work? Does it have features I want? Or maybe what the customer wants is some experience, like a theme park, a ride, or a play or something. Or it could be a status symbol. Does anybody in here have a really expensive watch on? Well, maybe you don't want to raise your hand, but I don't want to make anybody a target. But a watch tells time, right? So when I wear a watch, it's a cheap $30 Timex. But there are people out there that are buying these $340,000 watches that are made by Bugatti. They're only making like $250 a year. $340,000. Give me a break. I had it in here. If you look at this thing, you're going, well, the little timepiece on there is so small, you can't even tell time with it. So people are buying that for the status. That's okay. That's part of what a customer wants. There's a market for a Timex, and there's a market for these luxury watches. But then you've got to divide that by the denominator, the costs. Obviously, cost can be money, but also cost can be time. How long does it take you to do something? Oh, well, this one, I can get it done quicker. I can use it quicker. Well, that has value to you, right? The difficulty of using something. I'm sure that some of you have messed with IKEA stuff, and some of those projects are easier than others, right? Ultimately,
That resonates with this guy right here.
let me give you a tip about IKEA. Wherever you have two pieces of wood going together and you're going to nail it, you put some glue in there. Always, right, Lisa?
Too late.
That's your problem. So when you're defining value, you've got the customer's wants divided by what it costs them. And you obviously want to maximize the numerator, minimize the denominator. Ideally, you want to be both. Now, what's funny about this, and what you'll remember, my wife and I and our youngest daughter, we went to one of the theme parks. I guess we went to Universal, right? And we were in line for the Harry Potter ride. And it was awesome. So it was a big numerator value for us, right? But my gosh, the wait in line was so long. We came off of that, we go, wow, that ride was awesome. But the time that it took was too much. We could have gone on that ride maybe a total of 3 times that day and done nothing else. So, and we talked about this. We said, oh, it was great, but it cost us too much time. So we talked about the numerator and the denominator, and she's an engineer too. So we're very geeky in my family, and that's okay. I defend that. And so we decided to go on some other rides that maybe weren't as awesome, but they sure didn't involve as much time. And we were able to go on many more rides that day. So keep in mind, what constitutes value? It's what somebody wants divided by what it costs them. Please, I think you'll remember this and it will benefit you. Here's the trick though, when you're doing product development, the customer defines the value, not you. Because What you think is important may not be important to them. The Timex guy, he's not going to value the Versace watch or whatever it is. The Versace guy, he won't even look at the Timex watch. They're defining the value. What you can try to do is influence their perception of value. You can maybe educate them on something that you can offer them that they hadn't thought to ask for. That's awesome. So why are we here today? You have speakers on?
No, I don't believe so.
Oh my gosh.
Imagine, if you will,
Yes, we do.
a world full of problems that need solving, a world full of possibilities that are yet unfulfilled. Now imagine you have been given an insight, a way of looking at things with a clarity that reveals what's been there all along. Something that in hindsight you might be tempted to say, this is obvious. But then you must ask yourself, if this is so obvious, if so simple, then why haven't I known about it? We are about to enter a doorway into a new dimension, a place where that insight is real, and we call it the fail-safe zone.
All right, show of hands. I don't want to hear it. Who knows what that's from? Thank you, Lisa. All right, so tell me what it's from.
Twilight Zone.
Twilight Zone. That guy has been dead 50 years, so I got him to do this custom for me. Actually, I got to use some AI to make that. I was pretty proud of it. This is one of the tools that I'm going to make available to you. At the end of this, I've got a barcode, so you can download this file if you want. You can download this presentation if you want. I like spreadsheets because they just make so much sense. It's so easy to do. And this is a spreadsheet I probably did 25 years ago. Well, I know more than that. And I call this fail-safe innovation, and you're going to find out why. Who can give me a definition of fail-safe?
Such a good product, even I could use it.
Well, no. When I first learned about fail-safe, I was younger than you guys, and we were growing up in the age of the Cold War and nuclear threats and all of that stuff. Fail-safe, we were learning about the nuclear bombs and all these weapons had a fail-safe, that if they failed, they would still be safe. Okay, I like to bring that concept in here because I'm going to show you how you can still be safe even if you fail. Well, how do you do that? Well, here's a simple spreadsheet. Again, I like spreadsheets. If you're evaluating a product, you want to sit there and say, well, what are the criteria? There's not one, there's multiple criteria that you're going to evaluate that product. And I'm talking about in a work environment, typically, you're trying to make some decisions, okay? So you will sit there and you'll establish what some of those criteria are. And I just threw up some examples. I always like to have notes which explains why this criteria is important to us. So I'm adamant, have that space, fill that in. And then you're going to assign a weight to it. And this scale can be whatever you want. It could be 0 to 1, 1 to 10, whatever's convenient. The key is when you're doing this as a group, you want to get group consensus. What are the criteria? What is the impact or the value of those criteria? You get group consensus. That's so important. The way you use this spreadsheet is real simple. You start out, you hide section 2 because it's distracting. You fill out section 1, and then you purposely reorder it because typically, when you fill this out, you'll fill it out in order of most to least significant. But you don't want that influence. There's all these biases that you don't want to let enter into the thing. You want to give everything an objective evaluation. So what you want to do is reorder that, some kind of a random order where you don't have the best at the top or whatever. Then what you do is after you've assigned that weighting value, you hide that column, because now that's going to be influencing people. You don't want that influence. Then what you will do is fill out section 2. You put your scores in there for how each candidate scored in that particular criteria. Like this one, candidate number 4 had the best score for the power requirements, and candidate number 1 had the lowest score for the power requirements. Right now, we don't know what that. Can't see that. We don't know what the value of that criteria was. And as you populate the spreadsheet, the numbers will show up, but also notice that I've got comments in here. This is important. So this is why the criteria is important. And this is why you assign these values. Okay, simple spreadsheet makes it easy to record and collect your information. So you fill out section 2 now, and then as you do that, the results are automatically displayed. But why is this valuable to do it as a group? If you do it as a group, it promotes objectivity. Now, some of you have been in a working environment, some haven't, but I guarantee you, you'll be in a situation and the boss comes into the conversation and whatever he says, nobody else's voice even matters. You don't want that. In this situation, everybody has an equal voice because you all represent an independent, valuable viewpoint. So you do not want to have one person's influence outweigh others. So you reach group consensus for all of these things. Extremely valuable to get a really objective outcome. And it prevents the gaming of the outcome. Oh my gosh. This particular spreadsheet I'm showing you is one that we did in 2000 or 2001 at a company I was working at. We had a couple of seats of Pro-E and the department was expanding. Pro-E was very, very expensive software. It was like $20,000 a seat and about $8,000 a year for maintenance. Really expensive at the time. We needed to expand and get some more seats. So my boss says, we got to do a clean sheet evaluation because this may not be the right way to go. So we evaluated Pro-E, SolidWorks, which was about 5 or 6 years old at the time, and Inventor, which was only a couple of years old at the time. We looked at some others, but ruled them out. So you can see, this is actually the spreadsheet we used. We put down our criteria. We used a weighting factor of 0 to 1. And then we started putting in some comments about these things. And we threw our numbers in here. So this was the rating, and this was the resulting score. The beauty of this, it's real easy to pick the winner. Objectively, nobody can game it. We had a guy that was a Pro-E user, and he says, if you switch from Pro-E, I'm going to quit. Well, he would have gamed this. He would have influenced the scores so that Pro-E would come out on top.
Did he quit?
Yes.
Okay.
And that was addition by subtraction.
There you go.
So picking the best is easy, right? So this is a very simple decision matrix. That's all that I've shown you so far. But we're going to turn this into a fail-safe innovation matrix. Now, this is also a matrix that I used. There are more columns to it, but I abbreviated it for this display. I was given a task to design a new random orbital sander. The one that our company had, Sioux Tools, was a piece of junk. And it turns out my boss had designed it. I didn't know that. But the one we had was a piece of junk, and I had never, ever used one before. Well, I was a little bit anxious about that. How am I going to design a new one if I don't even know how to use these things? Well, it was easy enough to learn to at least the fundamentals. What I started to do then was collect information on what is already out there. I even had our companies on there, which isn't on here because it scored so low, it wasn't worth looking at. But we did this whole weighted criteria. And then we started evaluating all of these different candidates. And you can see, wow, it would have been really easy to say, if we were just making a decision which one to buy, the Dynagrade had the best score at 725, and the others were actually pretty close, pretty low. So it's like a number one, and then the rest of them was a pretty distant group. Now, all of you are pretty observant. You'll see that I got some of those cells shaded yellow. What do they have in common? Speak up, please.
Best in this category.
They're the best in each category. Thank you. You're getting it. So this is part of the fail-safe innovation. I can go through here and I can cherry pick from this list. I can say, I can't reach up there so high, but I can say, oh, look, it's made in the USA, or the 4 horsepower, 12,000 RPM. Those are what we want. Look, take those, put them on here. The vibration, oh, that's the lowest number. That's what we want. Put that on here. The noise level, all these other different pieces of information. I can cherry pick from this list and put it in here. And you know what? I win, because right now I have made a new combination that is better than any one of these competition. And what does this have going for it?
Everything.
Everything. Thank you. So it was real easy. I picked as you observed, I picked the highest scoring features from all the candidates, but this is key. Every one of those items is already proven. Talk about research and development. There was no development here. This is awesome. I have a better solution without any real effort. I love it. This new combination is better than anything existing. And this is what I call the fail-safe zone. Because if my boss came to me and said, Dennis, we got to freeze, we got to go. It's end of the year, we got to spend this money or else this project is dead. I don't care if you can do anything better, just what's the best you got? I said, boss, I'm going to make you look like a hero. We're going to go with this. He goes, that's awesome. You win. You have been successful. I'm safe. I get to keep my job for another week. This is the fail-safe zone. Look at this. You have picked the best features that are proven. Oh my gosh. People, this is so valuable, and it's like nobody knows how to do this anymore. It's like crazy. However, this is where I'm going to hit you between the eyes. Because if you can't do better than this, then you failed to innovate. And that's what a lot of you are interested in, is like you want to go above and beyond. This is above. And it's easy. But how do you go beyond? Well, if you've done your job well in evaluating that criteria, you're going to recognize that this fail-safe zone, that's low-hanging fruit. That's so easy. And you get to benefit 20/20 hindsight from what other people have done. Let's go to 2010 hindsight. And now we can apply some innovation because we're safe. Now, how many times have you heard somebody indicate that they don't want to try something because they think they're going to fail? Whether it's a sport or climbing a rope or whatever it is, right? People don't want to fail, so they don't try. But put yourself in this position. You cannot fail. So you might as well try. If you don't try, you should be fired. Because that's what you're getting paid to do. You're getting paid to come out there and come up with the new stuff. And so I'm looking at it like, if you don't try, the answer is no. If you do try, the answer might be no. But there's no consequence for failing, so I'm going to try because I might succeed, right? And that's where this comes into play. This is my superhero cape. No, she was like, that's not my superpower. There's a story behind this. I can tell you later. But think about this. What would you attempt to do if you knew you could not fail? Put your superhero cape on and go. You know, think of Superman. He can fly. He can jump off a building. Bullets can hit him and they just bounce right off of him, right? Well, that didn't work for us. But if you knew you couldn't fail, wouldn't you try some of these things? And that's what I want you to just kind of keep in mind. You get to a fail-safe spot, you can't fail. So here's the other part. At that point, like I said, you should be fired if you don't go any further, but it's kind of boring because what I just showed you is anybody can do.
Destroying the status quo because the status is not quo. The world is a mess and I just need to rule it.
Who knows who that is? Neil Patrick Harris. What character?
I'm not.
All right, look it up. It's awesome. Dr. Horrible. It's great. So just remember Dr. Horrible and go look it up. Now, this is a little warm, so I'm going to take it off, but I'm still a superhero. I like this quote of Einstein, and actually, when I went looking for it, I found so many different variations that I can't say that this is absolutely what he said, but it's close enough. Enough people have referenced it to him that I believe it true. You cannot solve a problem by the same level of thinking that has created it. And so what does that mean? That means you need to look at your problem differently. Change your perspective. So I have a lot of questions for you guys. One of them is, if you know who this is, please raise your hand. Maybe if I gave you a different picture of him. Now, does anybody know who that is?
Yes.
MC Escher, that's correct. What's he known for? But changing our perspective. everything he does. This guy is outside of the box, I mean to tell you. But I just use this as an example of change your perspective, change how you look at a problem. If you've done your job well with that spreadsheet, and you've been very critical with those evaluations and the weighting, you're going to recognize opportunities. If you look over here, we've got I just made a shorter list, very high value, high importance categories. And the best, they still had some low scores in there, didn't they? That screams opportunity. Hey, this is an important category. Even the best scored low. Maybe we can do better. So this is one from what I did. I'm going, the grip was so important on this sander. And so if you concentrate on those high value ones and look at the different scores, I was looking at the grip. There were two categories for the grip actually, because one company, Dynabrade, they had a molded on grip that's kind of shaped like the toe of a shoe. And another one had 3 different size donuts. Now, the way these tools are used, they're usually used in like a furniture assembly plant. And you have all kinds of people working there, and they're going to be using the same tools. And so you have somebody coming in with a small hand or a large hand, and the same tool doesn't fit them with the same level of comfort. And so this company tried to address it by offering different size grips. Okay, that makes sense. You have left-handed people or right-handed people, or for that matter, you want to switch your hands because you get tired. Well, my right hand and my left hand are basically mirror symmetry of each other, right? But my right hand, there's no line of symmetry for my right hand. And so when you go to grab something, it may not be as comfortable over here on my hand as it is over here on my hand. You'll see a lot of things that are like right-handed and left-handed scissors. That's a perfect example. It fits your hand with the thumb and the fingers. That's a great example, actually. But there's a left hand and a right hand. My oldest daughter is left-handed, and well, she loves her left-handed scissors. So I came in here and I'm going, what if I did something differently? Instead of having one grip that was molded on and it is what it is, it's not necessarily optimal for your fitting your hand, or having 3 grips. This is a problem too, because let's say that there's a large grip on there and you want the small grip. Well, you got to pry this one off, put the small one on, and that's assuming you can even find it. So this is a problem. And so I went and I combined the benefits, both of these. I took the hop around grip of this tool. I took the different size option of this tool. I thought, well, they made it removable so that you could get a different size, but I thought, well, why don't we just make it removable so that you can reposition it? I don't know if you can see, but you see how this grip is hop around? I can put it on this tool asymmetrically, and it fits nicely for my hand. And if I want to make it move for my left hand, I could just peel it off and rotate it. This was a big deal. This was a big deal. And especially in a mature market like power tools, there aren't a whole lot of innovations in power tools. And so this started getting some kudos, but it got the juices flowing. The other thing that happens with these tools is they typically have a coarse, standard, and a fine orbit. And I'm talking about the orbit of oscillation, not the grid. So they'll use a very coarse orbit to start out. And the tools are physically different. You can't take a coarse orbit and make it a fine orbit because the central element is machined that way. So the plants will typically have the different sanders. But the way these other companies have identified it, well, they did, some of them did the lever that you mash on, they would have it a different color, but there would be no other indication of what orbit it was. You had to look it up in the manual to say, oh, purple is for a coarse orbit and red is for a fine orbit. And after a while, you learn. But I'm going, well, why do you have to do that? Why not make it easy? And so I went to the element of, we've got a lock ring on here. This one's black, so it doesn't really show up. And why can't I mold in the letters that define the orbit? You can see it pretty well on here. This one says 3/8 coarse orbit, and it's gray. This one says fine orbit, 3/32, and it's red. This one is a standard orbit, 3/16. So now you can have these tools sit next to each other instantly. You can tell which one is which, and you quickly learn what it is because it tells you. It cost me nothing to do that. This lever, the previous tools, they had a lever, and this is one of the things that people weren't complaining about it. But I'm looking at it like, okay, they had this other company, they had a lever that fit into a recess in the grip. I couldn't do that because my grip was going to be moving, so I couldn't have that recess on there. But I'm looking at it and playing with it and I'm going, well, my hand is not flat. I don't need a flat lever. Why can't I make the lever kind of S-shaped? And by golly, it fits your hand more comfortably. People didn't complain about the other tool, but then they put this in their hand to go, wow, that feels better. Well, that's what the reaction you want. Also, in these plants, air motors or air tools, the plants use them because they're extremely durable, don't generate any sparks, but they usually have a repair shop. They can take this apart, replace the worn vanes or whatever, and put it back together. But these sanders, the way they're put together, that was very difficult to get the motor in there oriented properly, and you have to line up the inlet and the exhaust ports. And so I'm looking at it and going, you bring the motor in to the bottom and you've got to line it up just right. Well, shoot, I'm going to mold in an alignment mark. It cost me nothing to do that. And people are going, you even thought about it, maintenance guys. Oh, bless you. The point here, we put more thought into it, not more money. Because when we were showing this to our territory managers, they're going, Dennis, how much? How much? They wanted to know what it's going to cost. And I said, but wait, there's more. I was doing the Ron Popeil thing, but wait, there's more. And finally they got to the end and said, Dennis, how much is it? I said, oh, it's the same. You could have pushed them over with a feather. I said, but yours is so much better. I said, well, thank you. But how can it be the same price? Well, they've got a rubber grip. I've got a rubber grip. Yeah, but yours is better. They cost the same. They've got a plastic lever. I've got a plastic lever. Yeah, but yours feels better. But they cost the same. We put more thought into it, not more money into it. This was wildly successful. We sold 3 times in the first year what they projected to sell, and it's still a big seller for the company. And actually, Snap-on, they're not really an auto body tools company. They're more of an under the hood tools company. So for them selling the sanders was a big deal. Now, you guys will encounter this, I guarantee it. But I'm trying to open your eyes so you can be successful. Innovation is limited by your constraints, whether you know it or not. And that's one of the problems. We don't know. And so you need to challenge your assumptions, or they're going to challenge you. And I'm going to tell you a little story about a farmer that had a bunch of horses. He put up an electric fence. If any of you have ever experienced an electric fence, you know to stay away from it. And the horses did too. They learned pretty quick where that electric fence was. And by golly, they would stay away from it. You'd see, here's the fence, and there's some green grass that they haven't eaten because they don't want to get close to that fence. Well, after a while, he took the electric fence down. The horses, they knew where that fence was. They didn't go across that line. They didn't venture into that area. They stayed in their pasture. Shoot, the farmer, he's resourceful. He put that electric fence somewhere else. But these horses, they were good to go. He didn't have to mess with them. A few years later, he sold that place, and the guy that bought it, he thought, oh, this is great. Look at this. And he brings in another horse. And what does that horse do? He crosses right over into the other pasture and he starts eating the grass. And these other horses are going, what's going on? So they had assumed that that legitimate constraint was still in effect. Test those assumptions, test those constraints. And constraints can reveal your opportunities. Sometimes technology changes, and so those constraints, which were legitimate back then, are no longer valid. The example of the electric fence. Can you eliminate those constraints or get around them, or can you invent new methods? And constraints are not all bad because they force you to think. They're an obstacle that you get around, but you identify that obstacle properly and you go, okay, this is what I need to do. Go to my boss with an idea for something that I wanted the company to do. I believed in it. And I said, do me the favor of this, Bob, let me explain to you why I think it should be a yes. And in the process of explaining it to you, you'll see my line of logic and you'll be able to identify, even if your answer is no, you'll see what the impediment was that I didn't know about. And you'll be able to tell me, Dennis, I love what you're trying to do. This would be good for the company, but here's why it's no. And what you've done for me is told me, hey, we could do this if you can get around this obstacle. And I go concentrate on that obstacle, right? It's likely something I didn't know about. Problems are often described in terms of anticipated solutions. believe me. The Air Force, I worked at McDonnell Aircraft before Boeing bought them. We were making the F-15. And the Air Force had a 4-watt radar that had a 15-mile range at the time. And the Air Force wanted a longer range, and they came to Hughes Aircraft that made the radar, and they said, we want you guys to make some 8-watt radar. Hughes Aircraft is pretty smart. And they said, why? And the Air Force goes, well, we know that the range is directly proportional to the power, and it's got a 4-watt with a 15-mile range. So we want an 8-watt radar. And they said, why? Well, we want to double the range. And Hughes Aircraft kept saying why, kept saying why, kept saying why. Finally, the Air Force got frustrated with them and said, will you just answer our questions? And Hughes said, why do you want this? What do you really want? And they said, what we really want is we want over the horizon, look down, shoot down capability. And Hughes Aircraft goes, oh, well, we can give you that. We can't give you 8-watt radar because it won't fit. They developed new technology. But the customer was defining their problem in terms of a solution that they could envision. I saw this quote the other day, and again, I referenced somebody else because I saw so many versions of it. So when Henry Ford was developing the car, it's said that he said, if he had asked his customers what they wanted, they would have said a faster horse because they couldn't envision anything differently. He could. And look at what we all are benefiting from now, right? The point is, he didn't rely, this guy, Walter Isaacson, he doesn't rely on market research. His task is to read things that are not yet on the page. It's called really listening to the customer. I'm going to make reference to that later on, listening between the lines. I want you to go look this up because there isn't time to get into it. It's called the Kano model. And one of the things that they talk about in the Kano model is they talk about the unspoken, unexpected. I can't get into it just because there isn't time, but I think you guys will like it. So when you're working with a customer, instead of listening to them define the problem in terms of a solution, ask them to step back and have them define their dream state. What do you really want? It may not be possible, but at least you'll have a better idea and they will not have constrained you unnecessarily. And you guys represent the dream team, right? This should be right up your alley. All right, one of the other things about innovation is the rules are made to be broken, but what that means is you need to have a paradigm shift. Change the way you see things. Another question, who knows who this is? Picasso. This guy is a certified nut job in a beautiful way because he saw stuff that nobody else saw. He saw parts of a bicycle and he just grabbed the handlebars and the seat and he made this famous sculpture. And I love it because it's so simple. It's almost absurd, but I love it. He's seeing things that are right there in front of us, what you can do with it. And so I use that as an example of a paradigm shift. Innovation is difficult. Failure is the path of least resistance. Oh, I'm not going to try. Well, if you're not going to try, you are going to fail. So you need to be prepared to pivot, be prepared to change. Now, I'm not really going to get into it too much, but this is a product I designed called DTEC. It's a police car light. When I went to work for this company, my boss said, Dennis, I know you're a creative guy, but I know you don't know enough about police car lights to know what you can't do. We've got this new technology that we're fascinated by, and we have exhausted everything. We can't make it work. See what you can do. And I played with it for a little while, and I started learning some stuff. So I've never messed with lights and reflectors and all of this other stuff. And so I'm learning, well, how do lights typically work? Typically, you have a white light source. It shines into a parabolic reflector. The parabolic reflector reflects that light into a collimated beam, a parallel beam. Then on police car light, that beam, that white beam consisting of your color, red, green, and blue, goes through an absorptive filter. This is a small example of one. And you can even see on the screen, there's red coming through. This absorptive filter, the white light is hitting it, and it's absorbing everything except the red. So typically on a police car light, you'll have red and you'll have blue, right? So your white light source, you're either going to get red out of it or you're only going to get blue out of it. Well, we were looking at a new technology called dichroic filters. And the way these are typically used, it's a selective bandpass filter. It's typically applied to a clear substrate, glass usually. And that coating is designed to either selectively reflect or transmit a narrow range of color. And so we had all of these panels and flat panels, and we're messing with it. It's like, oh, I can separate the red light from the blue light, but I couldn't put it into a package that we could use. And this is where they had failed. They couldn't put into a package they had used. But then I started, I'm wrestling with this and thinking about it, driving to and from work. What have I learned? And what else are we trying to do? This is awesome because this is color selective. I get the red out of it. The blue is still there. I can extract the blue, but how do I do that? Oh, by the way, I need this collimated light. And so I thought, can I do this? So I took that parabolic reflector and I made it out of a transparent material. Typically, a parabolic reflector is made out of an opaque material because you don't care what it is because it's not going to transmit anything. You're going to put it with a silver coating and it's going to reflect. But what I'm doing, I took that parabolic reflector and I made it out of a clear material and I put this dichroic coating on there. And so now I get the red coming out on one side, I get the blue coming out on the other side. And this is what it looks like. This is a one of a kind. It's a prototype. I can fire it up. We can do that later on if you want. The colors on this are absolutely incredible. And if you see it, you can't see any real red or blue. We describe this as being like an opaque soap bubble, which was kind of nice too, because it was very stealthy. So if this is sitting on the rear deck of a highway patrolman and he pops those lights on, you go, oh my gosh, I am in big trouble. Because this one light puts out a red beam and a blue beam, and it'll cause spasms. But it was a big breakthrough. And when we got done with the patents, we had to do 5 office actions for the first patent, and that was unheard of in the first place. The patent office, they didn't understand it. Our patent attorney came to us and said, we're one of the largest firms in the entire Midwest. We have a 35-year history, and we only have 2 other patents that had this kind of breakthrough technology. So that was pretty flattering. But you don't see this on the road because LEDs came out and became affordable about a year after this. So, okay, it was something cool I did. It's not so big in the market. Oh, well, I have to do it. And you guys will recognize that people are resistant to change, right? That means also the people you want to change, your customers. You want them to change from whatever they're buying to buy your good stuff, whatever it is, software, I don't care. You want them to buy your good stuff. But you have to understand why they're resistant to change. They're focused on what they have to give up instead of what they have to gain. So now that's kind of the marketing side, is you show them what they have to gain and that they're not giving anything up. So think of numerator and denominator again. That you're improving the numerator, or you're decreasing the denominator. But you have to give people a compelling reason to change. I had a boss and he would come into me and he'd show me all these ideas for doing something differently. I remember when the oil bowl was going on in the Gulf, the Deepwater Horizon. He came in, he closed the 2 doors to my office and he started sketching this up. And he goes, what do you think? What do you think? What do you think? And I said, well, Pete, because he wanted to patent it and sell it to him to solve the oil well problem. I said, well, Pete, they tried that last week and it didn't work. But I would always ask him, he's always coming in with these wild ideas. He was a great idea guy, but he missed a lot of practicality. And I would listen to him and I would understand. I'd say, okay, Pete, now I understand why it's different, but I need you to tell me why what you're proposing is better. And he was all excited about coming up with something different. And I helped him focus on making sure that it was better, because if it wasn't better, there was no point in doing it. It's got to be better. But the thing of it is, better is something that you get to help the customer interpret. They get to define value. They get to decide, is this truly better? But you get to help influence that. Now, has anybody heard of Maslow's law?
Maslow's hierarchy needs, or is that?
When all that you have is a hammer, everything tends to look like a nail. It's a great metaphor. And I'm a mechanical engineer. Okay, so I tend to look at things with gears and levers and mechanical things, but I recognize the value of electronics and photonics and all these other things. I don't know enough about them to solve them, but I recognize enough about them that I know that in this situation, I need to get my double E friend, or I need to get my friend that knows about this stuff or programming or whatever it is. So my point is, maybe maybe I'm good at swinging that hammer and maybe I've got a few tools in my toolbox, but I really don't know how to use them that well, but I know when to apply them. So I get somebody else involved. And again, it comes back to defining your dream state. What could you do if there were no limitations? And I like this quote: if you want to make God laugh, tell him your plans. When I graduated, I had a master's in robot dynamics. I was going to be a robotics engineer. Well, it turned out that year there was an engineering recession going on. Only about half the engineers got job offers, whereas the previous year we all got 3 or 4 job offers. And the company that I most wanted to work for, I don't think they're even in business anymore. Needless to say, I never became a robotics engineer, but thanks to a few guys in here, I got to have a little bit of association with robotics at Creekside High School. That was a lot of fun. But my point here is your plans, I guarantee you that you guys are sitting here and you're thinking, oh, I'm going to do this. Some of you will, or you're going to come close. And some of them, you're going to go down a totally different path. And that's okay. Be open to that. And I'm getting close to wrapping up here. One of the things I want you to carry with you in your design philosophy in order to be successful in a product for your customer, whatever that product is you keep in mind, I want to make it easy for them to get right. But just as there's a coin there, you want to look at the other side of that coin. And I want to make it hard for them to get it wrong. Let me give you an example. A washer. Just a little washer that goes underneath the nut. You can't put that washer on wrong, right? If you can put it on there, it's right. The only thing you do wrong is put it out of order, but you cannot install it wrong. And yet there are other times, I'm sure you guys have done it, IKEA is a great example. You get ahead of yourself or whatever, you do something ahead of this one step, and oh my gosh, now I've screwed up and I got to try to return it. Maybe. But my point is, if you can put some effort into making it easy to get right and difficult to get wrong, well, what you've done is you've improved that experience in that numerator of the customer value. They go, man, this is so easy, even I can do it. This is so easy, even somebody from FSU can do it. All right, now this one, I'm going to rip through quick. So what most people call luck is when opportunity meets with preparedness. I always like that. And here's what I want you guys to do. Some of the things I'm passing on, some lifelong wisdom. Learn everything. You never, ever know what you're going to need. I was a lubricants research engineer. I could still give you a seminar on why you should do synthetic oil in your car and only change it once a year. You're going to say, oh, that's crap. I'm going, no, it's not. That was a long time ago. That was 38 years ago when I was a lubricants engineer. And I hadn't done anything in school to prepare me for that. Be curious. Please be curious. Stay abreast of the new technology. Always ask why, what if, how else could it be done? What could be done better? That's the kind of the motto of the engineer. My lovely wife showed me a t-shirt yesterday. What did it say on there? How can you, it was a pie chart.
They had a pie chart and it's how to reveal an engineers to pay attention. And one is to give them a cup of coffee. One, I forget the second one, but the third one was tell them it can be done better.
Yes. So telling the engineer it can be done better, or you figuring out it can be done better. Now, there's a lifelong lesson that I want to share with you in here. I was full of myself. My first job, I went to work for Amical Oil Research. It was a great job, great facility. Oh, we did some cool stuff. I was like 23, 24 years old. We had this technician and he and I had some words because I knew better how to do this. Well, we both had some points, but I handled it very badly. The arrogance of my youth, I knew better. I should have shut up. I should have listened. I should have phrased my suggestions in the form of a question. Hey, Paul, what if this? Or would this work? Or why not this? Rather than say, I want you to do it this way. So I invite you to make a suggestion in the form of questions, and you will learn a lot more in the process, and you won't piss off as many people. Challenge your constraints. We talked about the constraints. The electric fence is no longer there. Learn to do the research. You're looking at something, you're trying to develop a new product, go search for it on Google, go search for it on Amazon, and learn how to do a patent search. Google Patents is pretty easy. I know somebody's working on something else. Now, here's the key. When you find it, because you will, it's a matter of what words you search for, you will find somebody has done pretty much what you're looking to do. You didn't know about it. Don't despair. Because now I want you to ask yourself, well, shoot, what do they do differently? What am I planning on doing differently than what they're doing? What are the shortcomings of theirs? Why didn't I know about theirs? Maybe they just didn't market it. But these are great questions to ask, because when you start answering these questions, what do they do differently? What are they missing? What can I do better? You're identifying opportunities where you can make something better for the customer by pointing out something that's distinctive. I'm a big advocate for this, Taguchi methods. There's enough in here for you to just go look up Taguchi methods. I used to teach a college level class when I was at McDonnell Aircraft. We did it all in 1 week. It was intense. It was 36 hours in 1 5-day week with homework. I used to call up my professor back at school and say, Dr. Coble, you need to do this. Every engineer needs to learn this. And after 2 years of pestering him, he said, okay, Dennis, chill, man. We've got it in there. It's only a technical elective, but we got it in there. So, okay, I got to be satisfied with that. Invent new methods, learn design for manufacturability and assembly. I don't care what you're doing. If you learn design for manufacturability and assembly, the concepts will influence your programming, your electrical. The Kano model I talked about, I want you to read the goal. Quality function deployment, look that up. Immerse yourself in the field so that you can learn, but keep a healthy dose of cynicism and be skeptical. Because then you'll say, I'm not so sure. You don't have to believe everything that marketing is telling you. And the last thing, and some of you guys in here, I've given you this book, read the last lecture. It's a great book. You do some of these things, so you don't have to do them all. Do some of these things, and you're going to be prepared so that when those opportunities come, you can take advantage of it. You're going to be filling your toolbox. Maybe you know some of these things. The more you know, the more opportunities you can see, but also you don't have to be the expert. You need to know some people, develop relationships so that when you see an opportunity, hey, I can't do this, but Alex can do this, or Joseph can do this, or Ben can do this. I need to get their help. Know about other things so that you can recognize when they can be applied, and be alert for solutions from unlikely sources. I used to go into a sporting goods store and I'd play with the fishing rods and the reels in particular, because reels have some cool mechanisms in there. And I'm going, I'm not designing a fishing rod or reel. I'm not designing that, but I'm playing with it. And I'm going, the way they did this is pretty clever. I wonder if I could solve one of my problems over here by using this type of a mechanism. So be open to that. Take your big problem, bring it down to these manageable chunks, and then be open to where you might spot something for that. And this comes from the quality function deployment. It's an example too of what I talked about with the Hughes aircraft and the Air Force. Learn to listen between the lines. When we did this sander, the customer wasn't complaining about the lever or the grip, because what they had, they were satisfied with, and they couldn't envision anything better. But when I put this in their hands, they go, oh, I like this. They didn't really complain about it, but they would say some things in passing, and they'd say, oh, this snags on something. I'll go, well, I can fix that and eliminate that. Little things they can say in passing because they don't expect that you can fix it. So you learn to listen or ask some of those probing questions. Ideas are cheap. Dime a dozen. I know all kinds of inventors that say, oh, I've got so many ideas for this. And I'm just sitting there grinning and say, okay, well, put them into play, make them work. But you have to understand your capabilities. I had a guy, a junior engineer, designing a plastic part, and it looked like a machined part, all vertical edges and everything. And I said, Jake, where's the parting line going to be? He'd say, oh, I'm going to let the mold maker deal with that. Okay. What about your draft? You have to have draft. It's like a shallow angle so that you can eject the part from the mold. Oh, I'm going to let the mold maker deal with that. Okay. This was an optical part. And I knew what the answer was. I said, where do you think the mold maker wants to put the gate? And well, I wanted to put it over here. I said, yeah, but he's going to want to put it right here. So, oh, I can't have him put it there because it's right in the middle of the optical region. I said, yeah. And so you have to tell him he can't put it there, and you have to make it so that he can put it where you want it. We grabbed his mouse and it pulled up on the CAD tube. And I put the draft in, showed him where the parting line would be, and his jaw dropped. Because he really didn't understand plastic injection molding. And so he had to go back and do some major revisions. He did not fully understand the capability of his process, nor its limitations. And if you don't, you could draw all kinds of stuff on the CAD tube, but if you can't design it in a way that it can be manufactured, you're really just a cartoonist. This is awesome. You can't be experts at everything, so you get your vendors involved. Ask them, because they're experts. I was dealing with the vendor, powdered metallurgy, and I started asking, what's the state of the art in your technology? And I got ahead of myself and I defined for him what my dream state was. I said, if you really want to make me happy, you'll tell me you got side action PM. And the guy sitting across from me was the president, and the head of engineering was sitting next to me. He says, Dennis, the reason Blaine is smiling is because he's about to make your day, because we are doing side action PM. And the stuff that we could do with that was just opening huge doors. I want you to push, try to invent new methods. Think of 3D printing. You can 3D print stuff that could not be manufactured otherwise. Look at the software that's available to you, the machine learning, the AI. You can do things either faster or differently than you could ever do before. Now, I don't mean to burst your bubble, but there is no magic bullet. There is no one formula that say, you do all of this, you'll be a good innovator. Those ideas mean nothing without execution. This last slide. This is really important because it's conceptual. You could go get different numbers, but they're all going to be generally the same. It's called a shadow diagram. So when we're sitting here designing a product, and at the end of it, we release it, we do a cost roll. It turns out that we put in a little bit of money to pay for our R&D. The cost of the product is in the materials and the labor, and then some overhead to pay for the bigwigs that are saying, yeah, do this, do that. However, the shadow is the influence on society. Maybe we, in our design, made a decision to use a cheap plastic, and it cost us pennies different than a more expensive plastic, maybe that had better properties, more durable. Well, now this is if you will, this is a Timex instead of the Rolex. And the customer is going to see that. We made a decision that influences them. Design has a huge influence. All of this is like, well, this is part of the cost of doing business. But design has a big influence. I love this shadow diagram. When it was first shown to me, it was just like a ton of bricks because it was so true. And it brought home how important it was. When you're doing the design, you get to influence the customer. They decide what's valuable. They decide what's better. You can try to influence them. You can listen to them and understand them and try to provide that. Ultimately, they're making the decision. So now, I'd like to have, Alice is going to do a little paraphrase.
Actually work a little bit.
Yep, earn your keys. So I'm done. And I want to have, so you guys can, I'll make this available to Alex. He's already got access to it, but this will take you to a Google Drive where you can download these files if you want. But what I want to hear from you guys is, what are some of the things that you learned today, or what are the things that caught your ear?
Let's talk Arian in the background. This is his whiteboard. Everybody say thank you, Arian.
Thank you.
Thank you, Arian.
Everybody say thank you, Dennis. He's done a phenomenal job so far as well.
Thank you, Dennis.
Okay, so what was your key takeaway, Arian?
Key takeaway gotta be. I think that the value equals wants over needs, like we said. I mean, it really, a very simple way to put it, but it definitely shows the importance of really weighing those equally and putting in the mathematical notation that's very simple. The cost might be heavy, even if the value is there, in the end, the value might not be there, right? So you really have to maximize the universities.
Allie.
One big takeaway was that okay, I'm so sorry, my mind just went blank. That you have to really put in the extra effort, and the rewards would be great. Like for the mold, there wasn't really a great need for it, but if you put in that extra effort, it'd have great effects, even if it's like something that someone's not saying like, oh, I want this.
Yeah, you put person with the worst handwriting, but I said 1% better equals 100% difference. So if you make something that's just a little bit better, maybe you capture all the market. I really do like that. That's awesome.
I really like the ideas are cheap. Just because I feel like I kind of resonate with them and think I have a lot of ideas, or I feel like I should do something instead of executing it. Like, something that's important, my sense.
Start doing something with those ideas. What do you stand to lose? If you do nothing with them, you haven't gained anything. If you do something with them, you might. Tyler's got something.
I really like the fail safe. I think it's interesting that you can kind of establish like a minimum, like a, baseline where even if everything goes wrong, you could, that still works. And then from that point, you can actually create something new.
And it's a spreadsheet.
And it's a spreadsheet.
Back here.
Yeah, I like the spreadsheet also, but I actually have a question.
Yes.
So when you're combining everything, they'll say, do you ever find issues when you're combining like the different pieces?
Yes, you can easily combine things or try to cherry pick the things that are incompatible. Like if you do this, you cannot do this. One of the first places I use this is the only top secret project I was read in on back at McDonnell Aircraft. We were doing a quality function deployment, a QFD project with the Air Force. They were the customer. They had two design groups, the Phantom Works in St. Louis and some other think tank out in Long Beach, California. And they came together. And these guys hated each other. They're all brilliant, but they hated each other. And what was going to happen was one group was going to present two of their ideas, and the other group was going to present three. And what everybody expected to happen was that we're going to down select to one from each one. And then they were going to go back and concentrate on those. But what Eric and I did instead was we did the categorization and the scoring and the weighting. And after that, they said, oh, well, it was pretty easy to see which one is the best. We didn't even show them that. We just went straight to the cherry picking. And we did two configurations because some of those things were incompatible. And what we came up with was two new configurations based on elements of those five. And both of those were better than any of the five. And they were combined from elements of both teams. The Air Force customer was ecstatic. They were so happy about this. And these other teams were now working together. So it was a win-win all the way around. But that's a very good question. I'm glad you brought that up because sometimes you do have that incompatibility. You pick this, you can't pick this. So give yourself options. You don't have to pick one best combination. Pick another best combination as well.
I'm sorry to derail your activity, but I also had a question. It seems as though as you have like sold a lot of products, and I'm sure in that process you've had to like sell yourself and your like experience as well. So I was wondering how, like, what kind of parallels do you see, or like what advice would you give students who are going into interviews to be able to sell themselves better?
In an interview?
In an interview or in a company, however, like,
well, if you're going to go talk to a company, you want to learn everything you can about them, learn everything about the position and what they might be doing in that particular area. And do yourself a favor and find out what their competition is doing. Because if nothing else, you can raise some really good questions. Because in an interview, they like having really good questions. Okay, but that's part of, to go back to some of this other stuff, that kind of is immersing yourself in it. And yet you're still holding yourself back saying, I don't know everything. And so I'm not so sure about this or that or the other thing. So it's either areas you go investigate a little further or you use as a question for the interview. And speaking as a person that's had to interview people, I like when they ask really good questions.
Yeah, for everybody who's in here, here's a little cheat code on our interviews. If you ask really, really good questions, you stand out. That is a really, really big indicator that you've actually done your research, that you actually care, that you know where we're going, things like that.
Anybody else, please? Yes, sir.
Tom.
I really liked how different the idea generation process was. On one hand, I'm still reviewing with like that spreadsheet, but on the other hand, you say to imagine you're designing something with no boundaries, you don't constraints, how do you do them? I really like your spreadsheet. It really gave kind of a breakdown, but also the trick about it.
That define the dream state, because it goes back to invariably people will define the problem in the form of a solution that they can envision. And it's intrinsic on us to do that as well. We're trying to solve what we think is their problem, and we've got a solution in mind. Okay. And you need to step back and say, you know, what if these boundaries don't exist? And what do they really want? And sometimes you got to go back and ask them, what do you really want? And if you develop that relationship with them, asking those good questions, you get a better definition of what you're going to work on. Yes, sir.
So back on the spreadsheet, I like how they multiple fail safes against bias, because I know that bias is all in our lives, and it's good to have ways to protect the time process from bias.
Yes. So you heard me, and I'm glad you picked up on that, Ben. You heard me pick up on that spreadsheet that you have to have a group consensus for all of that. And what that group consensus does, it reaches objectivity, but it does help to blow through those biases. We're all going to have a bias one way. I'm biased towards mechanical stuff, right? I'm biased towards right-hand stuff. This guy apparently is a bias towards left-hand stuff.
And bad handwriting.
Well,
So, you know, that happens. We got like 5 more minutes, so, yeah.
Oh, okay, I was gonna say that to try to learn a little bit of everything, so that later down the line, it's not as difficult to change the design of the original product. And even if you don't know it, to spread your connections, so you do have something I know that they're doing.
thank you. I'm glad you picked up on that. Because you never know what the future holds. So be prepared. And by the way, I'm a Boy Scout.
So back to those different biases and stuff, would you say that there should be a greater emphasis on like the engineer's biases or the customer's experience?
Oh, definitely the customer.
Okay, that's what.
Definitely the customer. However, a lot of times the customers are idiots.
Yeah.
Because they have no idea what's possible. Okay, and so that's why you represent the art of what's possible. And so you can ask leading questions. Okay, you don't want to tell the customer, oh, I've got this for you, as much as it would be better if you would say, what would you think about this? So you present it as a question, as an option, and give them a chance to say, oh, well, I think so. But if you're saying, oh, you want this, now you're kind of shoving it down their throat. If you start having these questions with your customer, and keep in mind, they are idiots. They are, because they don't know what you can do. They don't know what's possible. You're sitting there going, oh, I'm designing nuclear reactors. You have no idea what a barn is. And BARNES, by the way. I remember that from my energy conversions class. It's like this weird unit. So you can talk to people that they don't have any idea what you're capable of doing, but what that should do is put you in a position to ask a lot of questions. And so you can kind of explore some areas. Well, what do you think about this? What would you like to have the ability to do this? That's a good way to say it. Would you like to have the ability to do this? And they go, no, that's not important to me. And you thought it might have been. Well, good thing that you asked, because now you're not going to waste any effort in that area, right? Or you're going to give it a low weighting, even if you offer it. But if you say, well, what do you think about doing, what do you think if you could do this? And they go, you can do that? Oh, you're going, chain, right? And you don't tell them how you're going to do it.
Mhm.
Because what you're asking them is, would you like to have this ability? But you're not telling them the means or the mechanism. And frankly, you haven't worked that out yet. You maybe have an idea. So the customer rules. And yes, there is an engineering bias, but what you can do is take that engineering bias and put it into questions to help extract more information, more meaningful information from the customer.
Okay. I kind of like want to give them that. I would like a lot of documentation that, like you mentioned, on the balance by the customer and not by the engineer. Like you might know all of this, and you might know like, oh, this will be better. So like it improves your life so much. But if the customer doesn't see that, there's not one you even mentioned.
Yeah, if I'm designing a $38,000 watch, I'm not going to sell it to a guy that's wearing a timepiece unless he just hit the lot. You know, and that's only one then.
I just wanted to add to the board that I really like the shadow diagram that you showed and how important design is. Like even though in the cost, like it doesn't seem like as big of a deal, like in the background, like the thought process you put into the design, like really makes it like what it's worth in the end.
Yeah. And just to use that, I learned about this when I was learning Taguchi methods to all things. I'm gonna give you a plug for that. There's no way to go into it, but Taguchi methods, you can take what you know about the scientific method and say, that's for rookies. Taguchi method is high information density. Every engineer needs to know this stuff.
As someone with a lot of experience in design, I'm wondering, what do you think of that production cost budget? Do you think that's good, or do you think the design should even take up a larger?
Oh, such general numbers. And like all general statements, they're 100% true.
Yeah,
Okay, so no, think of this as scale.
okay,
Okay, but no, but you're gonna find that there's a lot of validity to this.
Yeah.
That when it comes down to the cost of the product, the company's cost, not what they sell it for, but their manufactured cost. It's the cost of this thing was probably $38 in materials and $8 in labor. Okay, and we had like $15 in overhead. It was stupid, the overhead we had. So you're gonna find different values, but the relative relationship, what's really important is this versus that. That's the most important thing that I want you to take out of this. You as the designer are influencing the customer. You're making decisions that will impact them. So take that seriously. Are you trying to sell it to the Timex guy? Or you're trying to sell it to the Rolex guy? And there's all kinds of market in between, and I don't even wear a watch.
One more question, if anybody has anything? Yes.
You're okay.
Oh. This is one of my cherished possessions from my career. I've got all kinds of stuff. I got a box of all kinds of work souvenirs. This is a red pirate flag. That year in school, these guys gave me a gift as a thank you for me coming into the classroom and listening to them. And the first day I was in there, I told them, in my house, we fly the red pirate flag. And nobody knew what that meant. Now, don't quote me to say this is exactly true, but this is my understanding, that when the pirates are flying the black flag, it means they're gonna board your ship, they're gonna take all your stuff. When they're flying the red flag, it means they're not gonna mess with survivors. So in my house, it's like we say it the way it is, and we're not really too concerned about your feelings because we're telling you the truth. And that was and so that was kind of the theme with a lot of that stuff. And it was funny because I was given some very critical feedback. I could tell that some people were wincing at some of the things I told them. Is that, oh, that slide is bad. Oh, you haven't tried this. That won't work. You need to pivot to something else. I mean, I was brutal. And at the end of every one of those classes that day, I had somebody come up to me and say, Mr. Dennis, are you going to be here tomorrow? I said, well, I think so. Why? Oh, you haven't heard our presentation yet. So it didn't scare anybody off. Now, there's a time for tact, and I felt like that day I didn't have to be so tactful because there wasn't time.
Okay.
Oh, yeah. I don't get to fly any of the pirate flags at home, at least not with her.
Anybody take a picture of this if you want to. You probably can't read any of it, but that's all right. I'll type this up and we can post it on our Dream Team story, and we'll also post it for every member in here. Also, we're getting kicked out right now.
Can we get one last round of applause for Dennis?
Pictures of this room, I'd like to have some pictures.
Yeah, we're.
Do you have pictures?
Now,
Okay.
well, if you guys want to be funny about it, everybody put your